Okie dokie, guys, I've got good news and bad news. The bad news is we got a little bit further to go. The good news is twofold. Number one, this is not going to be as long as the last problem. Number two, you have worked so hard today with the quiz and with the new lesson that I bet if you ask your parents to take you to get milkshakes, they'd do it, even in this period of social distancing. You mark my word. Tell them they can email me if they've got any sorts of issues with that, okay? Um, so, just kidding, of course. Moving on. I hope you do get ice cream. You need a treat of some sort. So, when I look at this problem, we're going to start with problem number C. I love it because it kind of goes with what we've been doing. So, if you read, take a second, pause me if you need to, read it. Recognize that rocket A information is given in the table. But I am being asked about rocket B in part C. Now on rocket B, I have an acceleration, feet per second, and it says at t equals 0 seconds, the initial height of the rocket is 0 feet. The initial velocity is 2 feet per second. Now, I didn't underline the initial height because it says which of the two rockets is traveling faster at t equals 80 seconds. So if I want to know which is traveling faster, the initial height doesn't matter. I only want to compare the velocity of rocket B to the velocity of rocket A. Now, we're going to use the construct that new amount equals initial amount plus accumulated amount. And in this case, I would say the new velocity equals the initial velocity plus the accumulated velocity. Okay? So the new velocity would be its velocity at the 80 seconds. Its initial velocity would be its velocity at 0 seconds. Now to accumulate, I've got an equals instead of a plus sign. To accumulate velocity, you have to integrate acceleration. So my acceleration equation is 3 over the square root of t plus 1 dt. I don't think I've left myself quite enough room to work, do you? So I'm going to take that from time 0 to time 80 because those are the two specific times in the problem. So I hope you recognize that the square root of t plus 1 needs to be where my focus is. And let me call u equal t plus 1. I've got good news. Du dt is just 1, which means that dt is just 1 du. That's nice. I also know that since u equals t plus 1, I tell you what, before I write this, let me move this over. I now know that v of 80, which is what I want, is equal to v of 0. What is the velocity of rocket B at time 0? Well, it says it is 2 feet per second. Now, I'm going to make this 3 over the square root of u. dt becomes du. But I've got to figure out what to do with my upper and lower bounds. So if my upper bound was initially 80, I need to say u equals 80 plus 1, and I'm going to get 81. And if my initial lower bound was 0, then u equals 0 plus 1, which is 1. Okay? I'm going to rewrite that a little bit, and I'm going to say this is 2 plus 3, and then I've got 1 to 81. Instead of saying 1 over u to the 1/2, let's make it u to the negative 1/2 du. Let me integrate. So when I add to negative 1/2, when I add 1, I get u to the 1/2. Divide 1 by 1/2 and get 2. From 1 to 81. So that's going to give me 2 plus 6. And then I've got to say 81 to the 1/2, which is 9, minus 1 to the 1/2, which is 1. So that's 2 plus 6 times 8. So that's going to give me 50. What is it? 50 feet per second. And I saw that here because the initial velocity was in feet per second as well. Well, I still don't know which rocket's faster. So let me look at the table. And for rocket A, its red velocity at 80 seconds is 49 feet per second. So my conclusion here is that at t equals 80, rocket B is faster because it has a velocity of 50 feet per second as compared to 49 feet per second. Okay? So that is the review of today. I'm going to make more room. Now let's go ahead and do the other two because we are getting ready for the testing season. So it says find the average acceleration. Now, this is about rocket A over the time interval from 0 to 80. Notice, guys, that I was given velocity. If it had asked me for average velocity, since I was given velocity, that would be an average value question. And then I would do integral over interval. But since it said what is average acceleration, since I know that acceleration is actually the derivative of velocity, this is not an average value question. This is an average rate of change question. And I will guarantee you will have an average rate of change question, period, on the free response questions on the AP exam. Okay? So I'm going to say the average acceleration is equal to. So this is where you have to say y2 minus y1 over x2 minus x1, where your y's are your velocities. So on this one, it wants 0 to 80. So y2 minus y1 would be v of 0 minus v of 80 over x2 minus x1. So v of 80 from the table is 49. V of 0 from the table is 5 over 80 minus 0. So what is that? 44 over 80. If I just did that correctly. And divide by 4, I believe that's 11/16. And that would be in feet per second. So that's a nice review problem. It's not that difficult. It's just a matter of reading the problem and recognizes how it connects to what we've been doing this year. All right, so now it wants to know still about rocket A. And it says, using the correct units, explain this. Well, if I integrate velocity, the antiderivative of velocity is position. So that would be the accumulated position. If I accumulate velocity, which is a rate, I'm going to accumulate position from t equals 10 to t equals 70. Wait a minute. What do I mean accumulated position? Guys, accumulated position is displacement. It's change in position. So it's the displacement from 10 seconds to 70 seconds. Okay? So that's what that means. Use a midpoint Riemann sum with 3 subintervals of length of equal length. Okay? So if I'm going from 0 to 80, no, I'm going from 10 to 70. So from 10 to 70 is a total of 60 units wide. 60 divided into 3 equal parts would be 20 units wide. So that tells me that I need to subdivide from 10 to 30, from 30 to 50, from 30 to 50. I drew that kind of funny, my bad. And then from 50 to, am I saying anything right? It doesn't seem like I am. Yes, from 50 to 70. How about, I try this again, because I just did that really weird. So from 10 to 30, from 30 to 50, and from 50 to 70. That's a little bit better because otherwise I made a mess, and I apologize. So it wants a midpoint Riemann, so 3 rectangles. So I'm going to say that the integral from 10 to 70 of v of t dt is equal to rectangle sub 1, so base times height, plus rectangle sub 2, base times height, plus rectangle sub 3, base times height. Now, each rectangle is 20 units wide because from 10 to 20 or 10 to 30 is 20 units, from 30 to 50 is 20 units, from 50 to 70 is 20 units. So the base of each of my rectangles is 20. Now, if I'm going to use a midpoint Riemann sum, then I need to say between 10 and 30 is 20 on my first rectangle, and that means I use f of 20, which is 22. On my second rectangle, from 30 to 50, the midpoint's 40, and I use f of 40, which is 35, because that gives me the height of that particular rectangle. And last but not least, from 50 to 70, my midpoint's 60, and then that gives me 44. And from there, you're just going to simply multiply that out, add it up. You might factor out 20 and just say, well, 22 and 44 is 66, 66 and 35, and you add from there and then multiply by 20 once. But that is how you do that problem. All right, the last thought I want to give you is sometimes when we're working problems, you may notice that it's easier if you actually, and this isn't specific just to u-substitution problems, but if you think about what the graph looks like. So for instance, if I were to say, please find the derivative from -6 to +6 of x squared dx. Well, guys, I know that that means to do the area from here to here if those are my negative and positive sixes. Well, because x squared is even, I notice that the left hand and the right hand are going to have the same amount of area. So when I do 1/3 x cubed, I can go from -6 to +6, but sometimes it might be easier to just go from, and I said -6 and +6 backward, but it would be easier to go from 0 to 6 and then multiply that by 2 because plugging 0 in is a little faster on the bottom limit than plugging in 6 is. On the second problem, again, if I were to give you an example of, let's do the antiderivative of x cubed, I'll keep this simple, dx from -4 to +4. Again, if you think about it, I know that that function looks like this. So from -4 to +4 is going to look like this amount of area accumulated. Well, guys, if you see that, there's no point in figuring it out algebraically. I know the area below the x-axis will counteract the area above the x-axis and at 0. So look for tricks like that that might make some of your work faster and easier than you at first think it's going to be. All right. Yay! You finished. Now go get some rest and get a treat. All right. See you later.